This NEET Physics Basics by Master Prashant. In last class we studied about some Splient points. We studied about only 2 points. There are 3 more points. The third point of this is Newton's law, valid for only point particle. The Newton's law should be valid only for point particle. If it not valid for point particle, the law can be extended for only finite body, that is only one finite body, that is rigid body. The Newton's law valid for a point particle and a rigid body, that is a finite body. Then here for a finite body there is also a condition. There is a 2 conditions for this. First one, the force should be the force exerted on this should be external force to the body. To the external force, there is only external force to this finite body, and the acceleration of a special point. The acceleration should be at a special point. The acceleration should be a special point. That is center of mass. So we will detailly study about the center of mass in the upcoming classes. Now for this, there is a 2 point. The Newton's law is valid for a finite body with the 2 conditions, that is force is equal to external force and the acceleration should be at a special point, that is center of mass. The fourth Splient point is the local relation between the force and acceleration. There is a local relation between the force and acceleration, because for every difference, for every force at time has an acceleration of a at the time t. For every force at the time t has an acceleration of acceleration at the time t. So when the force changes, immediately the acceleration will also changes. So there is a local relation between the F and A, the force and acceleration. So this is so that the no sense of history of motion in the particle. If as for the F remains constant, there is no history of motion of a particle. So this relation is going to be a part of the fifth Splient point. We will see the fifth Splient point. Now we studied that there is a local relation between force and acceleration. From this, force is equal to, we studied that dp by dt, the delta of momentum by delta of time. This one we can write, the dt we can take it to the force, multiply of force, then then we get force into dt, F into dt. So there is a time between this which changes from T2 to T1. So it's equal to the momentum, the delta of momentum is equal to the force dt, delta t. So for the P, the momentum at t is equal to t2, because the momentum at t is equal to t2, and the momentum at t from here it is t1, because it is equal to. So we get that integral of f dt is equal to integral of dp. It's equal to the momentum t2 minus momentum t1, so we get a new idea, that this is called as impulse. That we get a new formula, this is called as impulse. From the fifth point we get Newton. This we call as another way of Newton's second law. The impulse of a force acting on a particle from time 1 to time 2 is equal to change in momentum of a particle in this time interval. the impulse is the f dt integral f dt. Impulse of a force acting on a particle from t1 to t2 is a change in momentum of a particle in this time interval. It's equal to the time interval change in momentum. So it is another way of second law of motion. And when the f is constant, the integral f dt becomes f del t. Then the impulse, if the force is not constant but there is an average force, then impulse become the force of average into del t. Thanks for watching. Please subscribe my channel for more videos. See the end screen.